The aperture in a pinhole camera is a diameter of 0.6 millimeters. And here's some light sources that are on the screen, some distance away. They are separated by this X here. And they both have this wavelength of 600 nanometers, but we're trying to figure out what this distance L is from the camera to the screen. So let's realize that we have this little angle here, and we have to calculate that. So first we'll start with that. It's usually in radians. I'll just put that here. And that's supposed to be equal to 1.22 lambda over d. And this is for a just resolved circular aperture, and that would be for a camera. And so we know it's just resolved. So let's try to figure out what the phi angle is. 1.22 times 600 nanometers divided by 0.6 millimeters. Let's do that on the calculator. 1.22 times the 600 nanometers divided by 0.6 millimeters. So we get something like 1.22 e to the negative 3. And this is radians. From here, let's try to remember the arc length formula. It would be something like S equals R theta. In this case, the S, for small angles, let's try to do a small little approximation here, small angle approximation. We'll see that it's basically the same thing as X right here. That would be equal to the L, that's the radius, times this phi that we have here. So the separation is 2.95 centimeters. And we're trying to find the L, but we know that the angle is 1.22 e to the negative 3 radians. So let's just divide that over and figure out what the L is. 2.95 negative 2 divided by 1.22 negative 3 gives us a distance, this L, of 24.18 meters.